Welcome everyone to today's webinar on condensing boilers. Before we get started, my name is Andrea Silvestri and I'm going to go over a few webinar logistics. So today's webinar is based on research by 2 national lab evaluations, and the full reports as well as the 4-page findings and a 1-page infographic are found at gsa.gov, and I've also put the link in the chat window there on the lower right hand side of your window. In addition to the reports and the findings and infographic, where we have a list of upcoming webinars at gsa.gov. In August, we'll be hosting a webinar on synchronous and cogged fan belts, and these are a low investment way to reduce inefficiencies in ventilation fans. And since 12% of all electricity goes to fan ventilation, these are a low-cost investment in reducing electricity use. In September, we'll be hosting a webinar on next-generation chillers. And these chillers are 35% more efficient than FEMP-designated chillers, and were both shown to have payback under 5 years. And in October, our webinar will discuss findings from multiple GPG assessments of electrochromic windows. And these windows respond in real time to weather and user preferences and tint like smart sunglasses. And you can also find webinar recordings and slides from past webinars at gsa.gov as well. GPG webinars now offer continuing education credits. They're available through the American Institute of Architects. If you wish to receive credit after the webinar, you should receive a short survey, and by completing that survey, there's a question whether you'd like to receive credit. If you don't receive that survey, please contact Michael Hobson to get credit. During today's webinar, the broadcast is set to listen only, but if you have questions, you can submit them in the chat box on this lower right-hand side of your screen, and you don't need to wait until the Q&A session to submit questions. In fact, it's great if you can submit your questions as we're going along. And now let's get started. Mike Lowell will be facilitating today's presentation as well as the Q&A.
Thanks, Andrea. Next slide.
And Mike, you should be on the agenda slide now.
Oh, okay, sorry. Here's our agenda for today. Today's webinar will include a brief overview of GPG by Kevin Powell. After this, Dylan Cutler, who was the principal investigator from the National Renewable Energy Lab, will summarize the GPG assessment of condensing boilers at the Denver Federal Center. And we'll also summarize the research results for both the evaluation in Denver as well as an earlier assessment by P&L at the Peachtree Federal Building in Atlanta. Dylan's presentation will be followed by the on-the-ground feedback from Doug Bachman in Region 8, where they've been using condensing boilers. And lastly, at the end of the webinar, we'll have an interactive Q&A session. And with that, I would like to introduce you to Kevin Powell, the Program Manager for Emerging Technologies in the GPG program.
Well, thank you, Mike. And I want to give a big thank you to this whole team that pulled this presentation together and that did all of this research, and of course all of you for being on this call. So next slide. Just a few words about our program. You can see the mission statement up there on the screen. I think the key term that I hope all of you take away from this really is that what GPG is organized to do is to help our agency and actually the industry more broadly make sound investment decisions in next generation building technologies based on not their advertised performance, not their performance in a laboratory setting, but based on their real-world performance. That is to say, how do they work in the world where we have to buy them, install them, operate them, and to the degree that they affect tenants in terms of how tenants interact with them, are they cost-effective and are they cyber secure? So when we take a technology to the finish line, and when it has a recommendation, as this one does, that it has in fact delivered, that it has proved out, it means that the legwork is done in advance, that you know that it can be installed, operated, that it will deliver clean performance in a real-world setting, and that it has good financial payback, that it is cyber secure. Next slide, please. So just, again, a quick note on why we do this program. What you can see here is that on the left side of the graph, there's really a fair amount of investment in research and development. Comes from the private sector, comes from the federal sector. There's a lot of innovation. And that is really driven by the fact that the marketplace views owners of commercial buildings, in this case, in our case, as wanting to make a better building than the last one. And of course, everybody is being challenged, both in the federal sector and in the private sector, to do more with less. So how do you do that? Well, you do that with innovation. Innovation drives efficiencies, lets you do more with less. The problem is that 4 out of 5 technologies never cross this, what's called technology valley of death. That is to say, they never really get from either a working prototype or perhaps a actual market-ready technology that early adopters can in fact buy, but they never get to a place of mass adoption. Therefore, they're never really fully available. They're not inexpensive. The channel partners aren't really there, because that is what we really, really need to drive that innovation into our buildings to achieve the kind of efficiencies we're looking to achieve. So GPG was set up in order to bridge that gap. We are the largest single owner of commercial real estate in the country, and because of that scale, we're in a unique place to actually invest in the research to vet next generation technologies, and that is what this program does. So we're very excited. We work with the Department of Energy Better Buildings program. We work with folks across GSA to deliver this. We work with the private sector in terms of their ability to provide those technologies for our evaluation. We work with a sister program over at Department of Defense. And all of that lets us really deliver the confidence that hopefully will allow us to all achieve what is in what our previous commissioner called our enlightened selfish interest. That is to say, we want better buildings, we want the technologies that let us do more with less, and we want the marketplace to have the confidence that lets those technologies be delivered at scale. So next slide. In terms of how this program works, how did we get to condensing boilers? Well, we have essentially a 4-step process. First is we identify through a request for information promising technologies at the edge of commercialization. Condensing boilers was one of those technologies. It's actually one of the earliest technologies to have been incorporated into our program back in 2011. We publish this request for information every fall. There'll be another one coming out this fall. I am proud to say just got that determined today. We have subject matter experts score those applications, making sure that we pick the best of the best based on true expertise. We then cite them in the best places within our portfolio to give them a real acid test. And then we partner with Department of Energy National Lab to evaluate real-world performance objectively, and then recommend technologies with broad deployment potential for GSA and really, hopefully, for the broader marketplace. And without further ado, I think that should give a good sense of what our program does and why we do it. And I want to turn the program over to Dylan Cutler of NREL, who led this evaluation. So thank you very much for joining us today, and look forward to hearing Dylan's presentation.
Hi, good morning. Thanks, Kevin and Mike. Yeah, so I will, my name is Dylan Cutler. I'm a senior engineer at the National Renewable Energy Lab and led this technology demonstration. Next slide. This is just kind of to highlight that a couple of full-length reports were written on this topic, one by actually the Pacific Northwest National Lab and one by us at NREL, and they're available on the website. Next slide. So just at the very highest level, condensing boilers. So that's what we're going to talk about. I'm going to give a brief run-through of what we found in our study, and then Doug is going to follow up with some on-the-ground kind of feedback on how they've performed at the Denver Federal Center. At the highest level, condensing boilers are shooting to improve boiler efficiency, and they do that through capturing the heat that is lost through steam, basically water vapor and the flue gases, and they condense that back down out of the flue gases and put that heat back into the system, increasing the total efficiency of natural gas usage to heat delivered. They're about 15% more efficient than conventional boilers at rated conditions, and can be even more efficient in real-world applications. Next slide. So this is just a high-level snapshot of the opportunity. So these are some statistics, I think mostly pulled from the Commercial Buildings Energy Consumption Survey. So 35% of energy is used for heating in commercial buildings, and 33% of commercial buildings rely on boilers to provide that heating. I think for this audience, for the GSA portfolio, that 33% might even be higher, given that a lot of the GSA buildings are larger buildings, and in colder climates often. So a fair amount of opportunity here to reap some energy savings from this technology. Next slide. This is kind of just to note that these are the two different studies that were performed. One was at the Peachtree Summit Federal Building, and the other one was at the Denver Federal Center. Actually, 5 different buildings within the Denver Federal Center. PNNL executed the study for the Peachtree Building, and we looked at the DFC, the Denver Federal Center, and I'll be speaking to those results primarily. Next slide. Just to kind of give you a brief overview of kind of the data that we collected to do this M&V process. Basically, we collected data pre-retrofit utility data for all of the 5 buildings at the Denver Federal Center for a couple of years there. You can see the date range, and normalize that for the outside air temperature during those periods. And then while we were doing the study, after all of the condensing boilers had been installed, we were getting 15-minute data on all of these points listed in the little table below from the building automation system for a few months there. And so that is the acronyms there. It's outdoor air temperature, supply water temperature, return water temperature, and then some pump conditions and coil position. So these were the points that we were collecting from the building automation system to help with the assessment. Next slide. So this is kind of the takeaway on savings. In Atlanta at the Peachtree, they saw approximately 14% savings, and in Denver, across the 5 buildings, we saw 24% savings. The slide on the left is looking at natural gas consumption relative to the thermal load in the building, and those are lots of data points from the analysis. And the condensing boiler had kind of a lower slope, was using less natural gas per thermal load than the conventional 80% boiler, which is the solid gray line. For the graph on the right, you can see the annual consumption for pre-retrofit in the dark green and dark blue, and then post-retrofit once the boilers were installed in light green and light blue. The blues are the ones you want to look at because those have been normalized for weather. The savings actually in this case looked even bigger before we accounted for the fact that some winters are cooler than others. Next slide. And so the kind of economic evaluation of this technology is shown here. Essentially, I think one of the takeaways is that these are very cost-effective options when you're doing end-of-life replacement. So 4 to 6 year paybacks with end-of-life replacement. And this is only, in some of these cases, you'll see in follow-on slides that that the condensing boilers aren't providing a huge bump in efficiency compared to a typical, a high-efficiency boiler that's mandated by FEMP as if you're going to replace boilers, what you need to put into your building. They might not have huge efficiency bumps, but they still provide good savings and a short payback. And so really what you're seeing in this table is the costs for a high-efficiency boiler, the costs in the next column for a condensing boiler, the savings that we see for the condensing relative to the high-efficiency boiler, and then the payback is calculated as the difference between the incremental cost to go from that high-efficiency to a condensing boiler divided by the energy cost savings. And so the only one that really has the high payback period was that building 810 where boilers were not due for replacement, but just replaced for energy savings reasons. But so if you have any boilers that are really at end of life, all the data we've seen is that they're going to pay back really quickly. Next slide. So there's kind of a lot going on in this slide, so I'll hit on it pretty quickly. But we'll start with the graph on the left, and really this whole slide is looking at the efficiency of the boilers, of the condensing boilers. And so the title, it kind of says it all. It hinges on getting return water temperature below 130 degrees F. And why that's important is that's where the flue gases start condensing and you really get the efficiency bumps. And so you see in the graph on the left, you've got boiler efficiency on the y-axis relative to return water temperature. And so as the return water temperature goes lower, your efficiency goes way up. So if you're down at kind of the 80 degrees F, 85 degrees F, you're seeing efficiency from 96 to 98%. Can you go back up one slide? Whereas if you're all the way up at like 150 degrees F, you're going to be getting boiler efficiencies that are essentially the same as a high-efficiency near condensing boiler. So it's critical to lower your return water temp. The different lines on the graph are the percent loading. And so this is a little counterintuitive for some of us engineers, but you actually get higher efficiency with condensing boilers at lower loads. And so as you get down to low loading, they really perform well. And so what the graphic on the right shows is the percent time spent at different return water temperatures for the 5 different buildings we looked at the Federal Center and then the Peachtree. And so what this is capturing is that there's a pretty wide range in the buildings we evaluated of how well they're doing at returning the water back to the boilers at a point where the system is really going to function highly efficiently and provide that condensing aspect. So the, at the bottom, the DSC building number 25, most of the time we were actually getting return water temps above 130 back. And so, yeah, it's still a nice high efficient boiler, but you aren't getting all of the benefits of condensing. Whereas, building 710 and 810, they were doing a much better job at getting lower return water temperatures. And then the Peachtree was doing a really good job. And so that's kind of a key consideration, and one of the takeaways is that you really need to ensure, if you're going to pursue condensing boilers, you need to ensure that you're getting those return water temperatures down as low as possible. Next slide. Okay, so to continue on that note, because it's an important one, here's a couple of kind of recommended practices to ensure that. One easy one, which really is a controls implementation, is to use a reset on supply water temperature based on outdoor air temperature. And so, for the coldest day of the year, your design day, you need to be supplying your water temperature maybe at 180 degrees F. But as it gets warmer outside, you don't need that really hot water. And so you can basically do a controls programming intervention, almost no cost, right, that will reset your supply water temperature set point to lower values as the outdoor air temperature goes up. So maybe when it's 50 out, you only need to supply 150 degree water. And so what that does is it just ensures that you're getting cooler temps back and increasing your efficiency. You can also reduce the hot water flow rate. It's another way to kind of get at that same approach. And then for kind of deeper retrofits or new builds, a couple big considerations are high delta T coils. And so these are, maybe your typical coil, you have a supply water temperature of 180 and you get back 150. You can get coils that have delta T's of they're designed to have a delta T of closer to 60. So even when you're supplying your hottest water, you'll be getting back return water that will be allow the boilers to operate in condensing mode. Using two-way valves with variable speed pumps. So what this does is reduce mixing. And so with a three-way valve, what you're going to do is divert some water through the coil as needed, and then it mixes back in with the main loop. And so every time you do that remixing, you're going to bring your return water temperature back up. And so if you have two-way valves, what you end up doing is just kind of constraining the valves, tightening them down, which gets back to that reduced hot water flow rate. But if you're going to go that way, you really need variable speed pumps. Otherwise, the pressure on the system is going to just get too high. And then one last option is using a primary piping system with one water loop. Next slide. So this is kind of the best practices kind of takeaway for the condensing boilers if you're looking at installing them. Really looking at conducting a load calculation to make sure you meet the maximum load without putting a whole bunch of excess capacity in. So actually do that engineering step. Select boilers with low turn-down ratio and minimum flow requirements. And so this goes to the fact that they operate better at these low turn-down ratios. This enables you to stage your boilers, kind of do a modular approach where you have a few smaller boilers, and you can turn them down low and operate them in parallel, is kind of the recommended operating strategy. And each manufacturer will have their kind of control strategies. Should be pretty well nailed down, but that's kind of what we saw most effective, is kind of a modular design with all of the boilers operating at pretty low turn downs. And then the minimum flow requirement enables you to head towards more of that one piping loop concept where you're not having to flow a lot of water through the boilers at low loads, and again, aids in getting those lower return water temperatures. Using stainless steel for all the vent stacks, this is kind of a must because the condensing of the flue gases kind of creates a corrosive environment, and so you need the stainless steel. That is kind of one of the things that adds to the costs of these boilers, but it's a must. I already touched on operating multiple smaller boilers in parallel, and then consider kind of addressing most of the building load with these condensing boilers, to kind of maximize your economic investment. Next one down. Yeah, so kind of the takeaway that we saw is these are really well suited as end-of-life replacements, but that it's key to kind of look at not just the boiler selection, but your larger building environment, and does that building lend itself to kind of getting these low return water temperatures back, or easy retrofits to enable that. So they really showed good economic performance and good technical performance, especially in these conditions. Next slide. And that's it. I can turn it over to Doug Bachman to kind of give you some feedback on how these have operated at the DFC.
Am I on now?
Yes, you're on.
Hello? Okay.
Hi, you're on. Yep.
All right. Yeah, I'm Doug Bachman here at Region 8 here in Denver, Energy Program Specialist for OFM of GSA. And next slide. Yeah, years back, we were all excited to start changing out the old boilers that we did have here because of their size and the maintenance and everything that was involved with it. It was really time-consuming, and there was a ton of energy being wasted heating up these big mass pieces of equipment just in case you would need the extra heat to, depending on how the weather was. So it was like you turn them on and left them on for the whole season. But we were all excited about this, and as we were putting together the project and understanding the, what the condensing boilers are, and how many that, we could take out a boiler and put in maybe 2 smaller boilers that would allow us to lead and lag or stage off and on for the heat load. Go ahead to the next slide. There was common mistakes that were noticed as the project started to develop, and pretty much every building and the way that it's piped or installed would be different because of just the design of the building. So we had buildings where the original boilers were just directly vented, and then we had other buildings that had multiple boilers in that had breech stacks together. And in a conventional boiler like that, you could get away with manifolding the stacks together. But what we had found out that with the condensing boilers, that is not the case. So you want to look at the spot and the way that things are going to be installed, and you want to have an individual stack, and that it's going to get kind of interesting is maybe of what you got to penetrate through to have that installation done, or the facility that you're doing. And out here we've installed these in a lot of labs, and so naturally we had aesthetics, and we had to do a few different things as far as running our stacks go, and that it proved to be, not like the picture in the installation book where, there it is, stack in, stack out, and you're done. But like on this slide showing, and go ahead to the next slide, and we'll pick up there, if you would. The contractor, it was one of those things at the end of the contract where you don't have a bunch of money left, and this building suffered from that, is that it was kind of said, oh, you'll be fine with the galvanized stack that you got going, and so they, once again, you can see where it's all breached together on that one slide. Well, you'll see on the other picture there that, that's how acidic that the condensing water is, that it's being put up the vent. And throughout this whole manifold system, the seals were getting eaten up, and the bottom of the ductwork was getting eaten, and it was leaking all over. So it's really important. Plus, it's code that you use the stainless steel, and why this happened, I don't know. We were asleep at the wheel, I guess. But a thing that was going on here, with all the excitement that was going on with us installing the new boilers, we knew that there were new technology coming off the manufacturer's floor. And, so we thought, okay, well, when they actually got here and we started installing them, we weren't aware that the R&D department didn't have the controls actually all processed and programmed. And so when you're looking at new technology or new equipment and having it ready to, be installed, and you're going like gangbusters on it, that, that the whole thing has been gone through. Otherwise, you would, really set yourself back in time a little bit. So it was rather interesting, though, to watch the installers talk to the R&D department back in like Wisconsin on what and where they were landing and how they were going to program it. So it was interesting to watch, but if the times would have been different and the season would have been different, it would have been, a pretty tough go for us. So just the work of the wise to check that out, as far as the piece of equipment that you're going to spec out for that. And, that it could set you back a little bit. Next slide. Okay. About a year and a half ago, I did a project that went back into that room, and we redid the ductwork properly. And as you can see from the other picture, there was no drainage at the bottom of the duct. There wasn't, anything that was saying, hey, we're going to have water condensing coming back from this flue. So all this ductwork has rubber gaskets in them, so when it snaps together, it's all sealed. And then, of course, the sealing of the ductwork on the outside, too. So it is a specialized ductwork that's called out for in code and in the installation manuals. What you see on the right-hand side there is with all condensing boilers here in Denver, I would imagine everywhere else, since it is acidic, you're required to have a neutralization tank for it. So as the water condenses and runs back, it's piped into one of these boxes here. And so it gets neutralized there and then it's allowed to go down a drain. If you don't do that, then especially in the older buildings that you're trying to put this stuff in, it probably doesn't take much to eat out your drain pipe, you know, from where you are right, you know, today's date, considering all the years that it has on it. So you want to make sure you do that. Next slide, please. Go ahead, next slide.
It might be taking a minute. We are on that next slide now, on the overall feedback slide.
Okay, sorry. Well, what, you know, based on what Dylan was referring to, the higher return air temp that was coming back, we were doing outside air reset, and we had to have a controls contractor come back in and reprogram a different reset schedule for it. So right now here in Denver, we're running at 0 degrees, we're running 180 degrees, or no, at 20 degrees, we're running 180 degrees, and at 69 degrees, we're running 130 degrees. So for today, I was informed that we had an 11-degree split from our supply to our return. So that, you know, so we're still doing a lot better. And our annual combustion test that we do out here, we're showing these new boilers at 90 to 93%, which, you know, that's pretty good for our altitude that we have here. You know, so once again, you want to factor in some of these things that are when you're replacing a piece of equipment, you know, such as like altitude. When we were taking out our old boilers, the non-condensing boilers that we had found out that they weren't even regulated for our altitude. So that's pretty astronomical faux that was affecting our gas consumption. So you want to be aware of those things that are going to make a little bit of difference when you're trying to see, hey, why don't I have this outcome or this efficiency that I'm looking at? So just want to comment on the exhaust stacks here, is that at this installation, we're at a small laboratory, and you know, when I first was looking at doing this project, you know, I was thinking I'll do an easy stub out and we'll just have them here on this slab, and you know, and thinking about the cost, of course, you know, like, oh, so I don't have to, you know, run these above the roof, peak, and all that. Well, you know, we have first impression guidelines and also, you know, a safety factor too. So people couldn't just walk right into the stacks that were standing up there. So we did individually run each boiler under its own stack up. But if you see the cones shaped, now this is a high airflow diffuser cap that they call it. So instead of, you don't want to have a rain cap on this, because you need to expel that steam and that heat. Otherwise, you're going to create that rainforest that's coming back through your vent stack. So what this allows to do, and you can see what I think this is cool, is that you can see the flue gas being discharged conventionally higher than just kind of floating out and hanging around it there. So I got to thank the contractor for bringing this. I mean, it's nothing special. It's just a special cap. So it really doesn't cost you any more to put that on it. So I thought that was a good thing to eliminate a lot of problems, because we wanted to get it out and away from the building as we could have. So what we're also finding here is that our maintenance is less intense. The one maintenance guy was saying, it's where we used to have one, we have two, but instead of rebuilding the refractory and having the linkage of the combustion linkage all recalibrated every year, and I mean that gets to be a mess. So these guys are able to go ahead and on most of these, they just kind of lift the lid on these things, and then the heater core is inside it, and they just kind of hose them out on the particular brands we got around here mostly. And so they may take some time, but now having that many boilers, they're able to, if they can't get to the one the next day, they're fine. On the bigger boilers, we're down for the summer. Now you can keep your heat up year-round, so when you have the colder mornings, like, believe it or not, we had here the last couple of days, we're able to fire that a boiler up for the tenant that's coming in, where before we used to say, well, it's, we just turn these things off in the beginning of summer and they stay off, so you got to put a sweater on. So these things are nice to allow you the option if things can, and you have to change things up for one reason or the other. And the most that really has to be replaced and repaired on these are just like the glow coils, the basically the spark plug type things. It's not a fire eye, but it's a proving sensor on them. It's so the O&Ms out here, they just make sure that they have these on, in their cabinet, and it's ready to go. So next slide, please. Back to the just to recap on all that, we've really seen a lot of savings on this. We've really seen a lot of, we've taken away a lot of that human error, of anybody getting in and messing with the controls or setting the, resetting the temperature on the unit itself. And all this stuff integrates real easy into the BAS system that you would have. So it's, come a long way from, the station engineer days. So we've been really, really happy with them. And we've went ahead and we're deploying these into all of the buildings throughout in Region 8 where it's applicable, that as the one slide that Dylan was talking about, you want to make sure that you're going to have the heat load. A lot of times you don't have the luxury of hiring somebody to come out to do a heat load calculation for you to make sure, or am I going to have enough return air or return water temp? But if you can, the more due diligence you can make up front can actually will size you a tighter unit for higher efficiency, and will probably cost you less for installation because you may not have to install that next size up. So those are some things, as we go and we deploy all this technology, that, you know, we do have that opportunity to gain this learning experience and the best practices. So I thank you all for coming, and if you got any questions, we'll answer them later. Thanks.
Now we've got the Q&A session. Let me call that up. First question, can everyone hear me?
Yes, we can hear you, Mike.
Oh, okay, great. First question from Sid was, why not three-way mixing valves? I know, Dylan, you spoke to this just a little bit, but if you could kind of reiterate that.
Yeah, so the three-way mixing valve, I think that really comes back to the return water temperature, and if you can get two-way valves with variable speed pumps, you can kind of avoid all the mixing of that higher supply water temp back into the water coming back from all the coils.
Okay, thanks.
Could I
just go ahead?
Yeah, Mike, could I interject on that? Is that,
oh, you bet.
With the two-way valve, and most of the colder climates, and actually that's when you'd be heating, right? So you'll want to probably keep that valve cracked a little so that you are circulating something through that coil. You don't want that valve to go to zero.
Okay, thanks. And then Jeff asked, have you, and we'll say has GSA used the Belimo energy valve to help reduce hot water return temperatures? I'll speak up only in that I'm the project manager on hopefully soon to be commenced test for the Belimo energy valve. That being said, we are testing it for a chilled water system. I'm not personally familiar with using it with a hot water system. I don't know if anyone else has any experience with that.
I guess this comment's a good one right after the three-way mixing valves. I guess I haven't personally tested the Belimo valves, but I've basically I think this is the general purpose of these are these kind of pressure independent control valves is like the generic name for what Belimo manufactures, and that they are trying to achieve the ability to have good stability at low flow through the valves. And so, you know, this kind of ties in. If you're going to go to two-way valves and kind of reduce the flow, you don't want instability down at low flows. You know, what that can do is you sometimes lose good control below 40% open with kind of some standard valves. And so then it starts cycling between closed and open and closed and open to kind of maintain control. And then you lose some of that reduced water temperature, and it's not good to be cycling your valves like that. And so generally what I've heard is that I've heard generally really good things around them. And there's a good article in ASHRAE recently on these valves. I think it was in February of this year. And then there was also a good white paper written that I think you can find on Belimo's website from one of the professors in the building systems program at CU Boulder. Gregor Henza wrote a white paper on these. So there's a couple good resources. I've heard good things, and it is a good thing that Jeff brought up there.
Thanks, Dylan. Next question, I think, Doug, this might be for you. If the boiler room is not on the roof, how are you venting the exhaust to the atmosphere?
Well, in the case with the pictures that I showed, there was a boiler room that was located outside of the main building underground with a concrete deck. But we had to create that doghouse that was housing the vents on that. So you have to, do what you can, to make it aesthetic and, to work. So, a lot of the boiler rooms that we have are pretty much housed in their own boiler room. So they're in the building or just off to the building. So we're not like having to run our stack up through a couple floor levels. But the thing that you need to worry about when you're running your stack is to make sure you got the distance and that your blower, your venter blower, has enough CFM to take it out, because with the elbows and the distance, you need to calculate all that in to make sure you're going to have enough to blow it out, regardless of how you stack it. Did that help?
Yeah, thanks. And then just a point by said, evidently, of course, they're using condensing boilers, and he said that they use welded single-wall aluminum for the chimney or the vent stacks. So an FYI for everyone. And then Carl's got a question. Do you have any data on the longevity of the condensing boilers? We've experienced numerous failures in less than 5 years. Doug, I don't know how long you've been, this will answer another question as well, how long you've had the condensing boilers, how long have they been operating?
Well, we started changing out in 2006, and the only problems we've had in the beginning was in the control end of things. We did change out some old steam boilers to the high efficiency condensing steam boilers, and there we had problems with the tubes. That seemed to be a malfunction, that whether it was just being new or whatever, but that was kind of a pain. And once you get away from that warranty, it makes it tough. So, but they're pretty trouble-free, man. And you always got a backup, so it's nice.
Right. And Andre, I know we weren't able to get anyone from Region 6 on the call, but Andre, I seem to recall in our discussions with them that they've been operating these since, was it the late 1980s? Does that sound right?
Since the late 1990s, right? So
okay, late
for
1990s.
For a long
okay.
time. Yep.
And I think we have Todd on the call, and you can talk to Region 4's experience.
And Todd, if you want to press *6, you should be able to speak.
Maybe not. And then Mark asked, and I don't know if anyone knows, but were the two sites, the Peachtree and the Denver, do we know if the manufacturers were different, or if they're, well, maybe Doug, we can say also, do all of your Region 8 manufacturers differ? Do you have multiple manufacturers? And likewise, do we know what the Atlanta manufacturer, who that was?
Well, in Denver, the main install was the Cleaver Brooks, and that's primarily what we have here at the DFC. And we do have another manufacturer brand that we put in Building 20 in the penthouse, but I forget what brand that is off, right now. So we kind of stayed with the one manufacturer, thinking that at least everybody could call the same service tech, and it kind of took the O&Ms having to go to different people. So it worked out that way for us. Not that, I mean, there's stuff out there that I've done my own research on that's very much, you know, right up to snuff and probably better. So.
And Mike, in Atlanta, that demonstration used the Harsco Patterson Kelly.
Okay, great, thanks. And then Sid was asking who the contractor was that's tuning your condensing boilers. I guess Doug, if you.
Yeah, that's Intermountain Service.
And they're probably local, right?
Yeah, they're local here in Denver. They're kind of like the service company for Cleaver Brooks.
Okay, thanks.
So that, yeah, it's just easier to get all the parts and stuff.
Right. And then Sid asked if you've got, Doug, a picture showing the full boiler room after the, after the 3 CB boilers were installed.
Yeah, I don't have it right now, but I can get it for you, sure.
Okay, great. So we'll get that to Andrea and we'll send it out to all the participants. And last question, it looks like, Jeff asked, are you maintaining a minimum combustion air temperature to prevent excessive condensation?
That's a very good question, and that's what's helped us out a lot here with the condensing boilers, not needing that big draft of combustion air coming in. So our boiler rooms are warmer, and we don't have that inrush of the cold air coming in. So, but you make a good point. So, due to the condensing boilers that we use, even though we bring in outside air, it's more of a minimum. It's a different type of ratio than the whole room and what the conventional boilers would need. So it's less, and we're able to maintain that room space, which helps out.
Great, thanks. It looks like no more questions, Andrea. I'll turn it back over to you.
Great. Thanks to all the presenters. Great presentations, and to everyone on the line. So again, if you wish to receive continuing education credit, you'll be receiving a short survey just after the webinar, and by completing that survey, you can ask to receive continuing education credit. If you haven't received the survey, please contact Michael Hobson, and he can get you set up with those credits. So thanks again to everyone, and our next webinar, again, will be in August on synchronous on August 10th on synchronous and cogged fan belts. Thank you.